Number 1. If the graphs of two linear functions are parallel, describe the relationship between the slopes and the y-intercepts. Well, since the lines of these functions are parallel, they'll have the same slope. But since they're two different lines, they will have different y-intercepts. So, for example, let's say we have y-intercept here and here, and we have two parallel lines. So they're going to have the same slope. If they had different slopes, obviously they would cross somewhere, they would meet somewhere. And let's say this is y-intercept B1, and this is y-intercept B2. So they have the same slope, so this is slope M is going to apply to both lines. And the y-intercept is B2. So y equals mx plus B2. That's your slope-intercept equation. And this one is the same mx, but the y-intercept is B1, which will be different. Number 3. If a horizontal line has the equation f of x equals a, and a vertical line has the equation x equals a, what is the point of intersection? Explain why what you found is the point of intersection. Okay, so we can call f of x equal a, just call that y equals a. We let y equal f of x, which is perfectly fine. And so we also have x equals a. We have x equals a and y equals a. All right. Now if you take the line x equals a, that contains all points of the form ay. So we have, if you want to use set builder notation, this is the set of all points a, y, such that y is a real number. And that style of writing there means the set of real numbers that are there. All right. So in other words, this coordinate, the x coordinate in the line x equals a, is the same. It's a constant. It's always going to be a. All right. But the y coordinate will vary. All right. It'll be any real number. That's basically what this is saying. So x will always be a, but y will be anything, any real number. All right. If you take the line y equals a, on the other hand, that's the set of all x a, ordered pairs, x a, such that x is a real number. Alright, so that is your x coordinate. The x coordinate is always going to be some real number. It'll vary, but the y coordinate will always be the same. Okay? So that means both lines must contain the point AA. Since A is a real number, all right, for this line x equals A, this is any real number, and so certainly A is going to be in there. It's going to be one of them, all right. So this has the point AA, and the line y equals a. The x coordinate can be any real number, so x will equal a sooner or later, all right, since a is a real number. So it will also contain the point AA. So both of these contain the same point AA, and that is where they intersect, all right. So that's why we know this is the point of intersection, AA. Number 5. Explain how to find a line perpendicular to a linear function that passes through a given point. Okay, so let's let the linear function be f of x equals mx plus b. There's our linear function, written in slope-intercept form, mx plus b, all right? And let's say the line perpendicular to it is to, well, let me write this down, line, I'll use the symbol for perpendicular to from geometry, upside down capital T. The line perpendicular to f of x must pass through a given point. Let's call it x1, y1. So it helps if you draw a picture of this situation. So let's say this is the line f of x equals mx plus b. Okay, and we want a line that's perpendicular, and it goes through a point x1, y1. It doesn't say where the point is. All right, it doesn't specify. It just is a given point. The point could be on this line itself, or it might not be. Okay, so I'll just stick it somewhere, like right here. Call that x1, y1. And we want a line going through. I'll draw it as a dashed line because we still need to construct it like that, and it's perpendicular. The little box there means it's perpendicular. Alright, well, we have a point that's on this line, and we know it's perpendicular to this line. What's the slope of that line? This line right here, it's slope m, right? So what does the slope of the perpendicular have to be? Well, it has to be the negative reciprocal of m. In other words, when you multiply them together, the product will equal 1, or rather negative 1. Negative 1, all right? So the slope of perpendicular line is, well, the reciprocal of m would be 1 over m, and the negative of that is negative 1 over m. Okay, so you've got negative 1 over m is the slope of the perpendicular line. Okay, and it's got to go through x1, y1. So we have a point and we have a slope, and that suggests using the point-slope equation, which is y minus y1 equals m times the quantity x minus x1. Alright, so we're not going to use this exact equation because we don't want slope m for this line. Alright, but this is the point-slope equation. Let me write that down. Point slope equation for a line is that. Alright, so this line has the equation y minus y1 equals negative 1 over m, that's our slope, times the quantity x minus x1. So since I chose the point x1, y1, I don't have to change too much in this point slope equation. It's already pretty much written out for me. Alright, so if you know the exact coordinates of x1, y1 as numbers, and if you know the exact slope as a number, then you can plug these numbers into this equation, and that gives you the equation of your perpendicular line. Okay? Number 7. For the following exercises, determine whether the lines given by the equations below are parallel, perpendicular, or neither parallel nor perpendicular. Alright, so for 7, we have 3y plus x equals 12. And we have 3y equals negative x plus 12. Or rather, no, that was my next step for this one. Sorry about that. This is negative y equals 8x plus 1. Alright. That's the second one. Okay. So the strategy behind these is to find out what the slopes are and see if they either equal each other, in which case they're parallel, or multiply them together and see if they equal negative 1, the product that is, or see if they're negative reciprocals of each other, in other words. All right. So we first need to get the slopes. To get the slopes, the easiest way is to go, is to convert these to slope-intercept form, y equals mx plus b. All right. So we want to do that one to do that to this one first. So I solve it for y. All right. Transpose the x to the other side, make out a negative x, and then divide both sides by 3 or multiply both sides by 1/3, however you want to think of that. So 1/3 times negative x is negative 1/3 x. Plus 1/3 times 12, or 3 into 12, is 4. Alright. For this one, it's almost in slope-intercept form, except slope-intercept form is y equals, not negative y equals. So you multiply both sides by negative 1, and now it's going to be in slope-intercept form. So both terms are multiplied by negative 1. Alright. Now, the slope here is negative 8, and the slope here is negative 1/3. Obviously, they're not equal, so they're not parallel. Are they negative reciprocals of each other? No, no, definitely not. All right, so these are neither parallel nor perpendicular. Number 9. We have 6x minus 9y equals 10. And our other line is 3x plus 2y equals 1. Alright, so we need to find the slopes of both of these, so we solve both of these for y. Alright, so we've got, leave the 6x on the left side, transpose the negative 9y to the other side, or just add 9y to both sides. You can look at it either way. And that gives you 6x equals 9y plus 10. Alright. Now we want to transpose the 10 to the other side, so 6x minus 10 equals 9y. And we want to multiply both sides by 1/9 to solve for y. Alright, so 1/9 times 6x is 6/9 x, minus 10 times 1/9 is 10/9, and 1/9 times 9y is just y. Alright, so 6/9 can be reduced to 2/3. So if it makes you feel better, you can write y equals the rest of this, and it's in slope-intercept form. But the slope here is next to the x, and that's 2/3. Alright, so keep that in mind. Now go to the other one. Solve this one also for y. So you transpose the 3x to the other side, make that a negative 3x. You've got 2y equals negative 3x plus 1. Multiply both sides by a half, you get y is equal to negative 3 over 2 x plus 1/2. Alright. Now, the slopes are not equal, so they're not parallel. However, notice that they are negative reciprocals of each other. You could go either way when you look at them. You could look at this, 2/3, and then take the negative reciprocal. The reciprocal would be 3 over 2, just flip it, and then put a negative in front of it. Alright. Or you could look at this one, and that'll give you, by the way, negative 3/2. Or you could look at this one. You could take the reciprocal, which would be negative 2/3, and then multiply it by a negative 1. Alright. Change that, put a minus in front of that, in other words. That becomes minus a minus 2/3, which is positive 2/3, and that's what that equals. And yet another way you can check it is to multiply them. 2/3 times negative 3/2 equals negative 1, which is what you would expect if they're perpendicular. Alright, so the product of the slopes of perpendicular lines will equal negative 1. Alright, so there you go. They are perpendicular. Number 11. We have y equals 3/4 x plus 1. And we have negative 3x plus 4y equals 1. So this is already in slope-intercept form, and the slope is 3/4, so we don't have to do anything with that one. With this one, solve it for y. You can transpose the negative 3x to the other side. You get 4y equals 3x plus 1, and then multiply both sides by 1/4. Alright, so y equals 3/4 x plus 1/4. Now, the slope of this is 3/4, and they're the same, so that means they're parallel, right? And it makes sense because they do have different y-intercepts, 1 and 1/4. Alright, so we're not talking about the same line, but we're talking about two different lines which have the same slope. So they are parallel, which is symbolized in geometry by the two vertical bars. Alright. Number 13. For the following exercises, find the x and y intercepts of each equation. So remember, the x-intercept is where the line intersects the x-axis, and there the y-coordinate will always be 0. And the y-intercept is where the line will intersect with the y-axis, and there the x-coordinate will always be 0. So we have g of x is 2x plus 4. Let's deal with the x-intercept first. Alright, again, that's where the y-coordinate will equal 0. Alright. Now if you let g of x equal y, what you want to do is set y equal to 0, or g of x equal to 0. That's where you're going to find the x-intercept. So you can think of that as y equals 0 if you want to. And what is g of x or y? Y equals 2x plus 4, or g of x equals 2x plus 4. So you just set 2x plus 4 equal to 0 and then solve for x. So you transpose the 4 to the other side. 2x equals negative 4. Multiply both sides by a half, or divide both sides by 2. Same thing. So x equals negative 2. So again, the y-coordinate for the x-intercept is 0, and the x-coordinate's negative 2. So the x-intercept is negative 2, 0. Alright? Alright, the y-intercept is usually a lot easier to calculate, because that's when x equals 0. Alright, x will equal 0 at the y-intercept. So you just want to figure out what is g of 0. Let x equal 0 in the equation, and then compute that, which is usually pretty easy. And so that equals 4. Alright, so we have the point 0 and 4. Number 15, we have k of x is negative 5x plus 1. So let's deal with the x-intercept first. And so we want to set k of x equal to 0, or y equal to 0. So what is k of x? It's negative 5x plus 1, and set that equal to 0, and then you just solve for x. You could move the 1 to the other side, or you could move the negative 5x to the other side. Let me do that. 1 equals 5x, and then divide both sides by 5, so you get 1/5 is equal to x, or x equals 1/5. Alright, so we have the point 1/5 and 0 as the x-intercept. Now for the y-intercept. So we just want to calculate k of 0 for this one. Let x equal 0 in k of x. So that's negative 5 times 0 plus 1. Negative 5 times 0 is 0. 0 plus 1 is 1. Alright? So x equals 0, y equals 1 is our y-intercept. Number 17, we have 7x plus 2y equal to 56. Alright, so the x-intercept. Now this happens to be written in what's called standard form. Standard form is ax plus by equals c, where a, b, and c are constants. All right. So when it's written in standard form, it's much easier to calculate the intercepts, because well, you'll see that the x-intercept was always kind of a hassle, but in this one it's pretty easy, because that's where y equals 0, and all you have to do is plug in 0 here. And then for the y-intercept, you just let x equal 0. So it's nice and easy, all right, relatively speaking. So we have 7x plus 2 times 0 equals 56. So that's just 7x equals 56. And if you remember your arithmetic, 8 times 7 is 56, so that's x equals 8. Alright, so we have the point 80, and then the y-intercept y-intercept occurs where x equals 0. So you just let x equals 0 up in the equation. 7 times 0 plus 2y is equal to 56, and that's equal to 2y on the left side. 2y equals 56. And so that's y equals 28. So we've got the point 0, 28 as our y-intercept. Number 19. For the following exercises, use the descriptions of each pair of lines given below to find the slopes of lines 1 and line 2. Is each pair of lines parallel, perpendicular, or neither? Alright, so this is similar to what we've done before. We have line 1. I'll call it L1. That passes through these 2 points, -8, -55, and 1089. So, how do we get the slope from these? It passes through those 2 points. If you remember the formula for slope, y2 minus y1 over x2 minus x1. That's the formula for a line joining the points x1, y1, or rather the slope of a line, joining the points x1, y1 and x2, y2. So we can use that formula. M equals y2 minus y1 over x2 minus x1. Alright, call that x1, y1 and that x2, y2. It doesn't matter really which one you use for x1, y1 or x2, y2. Alright, so this minus that, 89 minus a -55, and x2 is 10 minus a -8. So it's 89 minus a minus is plus, 89 plus 55, which equals 144. And minus a minus again is plus, 10 plus 8 is 18. Alright, turns out 18 goes evenly into 144, and that equals 8. Okay, so for line 2, call it L2. It passes through the points 9, -44, and also 4, -14. Okay, so again, M, slope M, is y2 minus y1 over x2 minus x1. And that equals -14 is y2 minus, -14, not -4. -14 minus -44 over 4 minus 9. Alright. And so this equals -14 plus 44, or 44 minus 14, which is 30. And 4 minus 9 is -5. So that's equal to -6. Alright. Now, are they parallel, perpendicular, or neither? They're not parallel because they're different slopes. They're not perpendicular because they're not negative reciprocals of each other. And so they're neither.